Hello friends, today we will talk upon the topic PN junction diode as a rectifier. It is a topic from our chapter Semiconductor, class 12th. So let's get started. A rectifier. A rectifier is a semiconductor device which converts alternating current or alternating voltage into direct current or direct voltage. Now the principle. It is based on the principle that a diode offers very low resistance during FP, that is forward biased, and offers very high resistance during RB, that is reverse biased. So let's talk upon half wave rectifier. Half wave rectifier. For the positive half cycle, diode is in the forward condition, and hence current will flow through the load, and hence we will get an output. For the next half cycle, polarity gets changed or reversed, and now the diode will be in reverse bias condition, and hence no current will flow through the load, and we get zero output. In this way, we get a pulsating DC output whose frequency is same as that of the input frequency. Full wave rectifier. For the positive half cycle, the diode D1 is in forward biased condition, and hence the current will flow through the load easily, and hence we will get an output. And this time the D2 diode is reverse biased. Then for the next half cycle, the polarity gets reversed, and now the diode will be reverse biased, and the D2 diode is in the forward bias condition. Hence, we will get the current from D2 diode. Now, since D1 and D2 diodes are forward biased one by one, but in both the half cycles there is current output. Therefore, we get, even if the polarity gets changed, we will get an output, but it will be DC, direct voltage current. But the frequency here remains the same. But as it contains central tapping transformer, so to avoid the use of central tapping transformer, we use bridge rectifier. In bridge rectifier, D2 and D4 are forward biased in the first half cycle, and at the same time D1 and D3 are reverse biased, and when the polarity gets changed, D1 and D3 are forward biased and D2 and D4 are reverse biased. In this condition also, both the time we do get the same current in the form of DC with the same frequency, but here no use of central wrapping transformer is there, due to which it is easier to use and it is convenient to make bridge rectifier than as compared to half wave or full wave rectifier. So we end with the topic PN junction diode as a rectifier. For any suggestions or doubts, you can comment in the comment box, and if you like, do subscribe it and click on the like button. Thank you. Bye bye. Hello friends and welcome to our channel SSP. I'm Vidushi and we will start with our topic. Today we will talk upon semiconductors. Semiconductor is a chapter of class 12th, and from that chapter we will talk upon the topic working of NPN transistor. Many of my friends suggested me to please make this video because it is very difficult for them to remember all these topics and points. So I'll try to make a video as brief as possible for to learn and to pinpoint the main things in that working of NPN transistors. To study the working of NPN transistor, let's get started. First, emitter base junction. The emitter base junction is forward biased by connecting it to battery VEE, and base collector junction is reverse biased by connecting it to a battery VCC. Voltage between emitter and base is VEB, and that between the collector and base is VCB. Now, electrons from emitter majority charge carriers enter the base region in a large number, constitute emitter current. Since there is a very light doping in the base, therefore very less majority charge carrier recombines, and most of them are further transmitted or further allowed to go to the collector. The base is very thin and lightly doped, therefore most of the electrons enter into the collector region, constituent base current. Now, since these majority charge carrier electrons mostly move to the collector, therefore it constitutes collector current, and it is found as a relation that current IE is equals to current IB plus current IC, that is collector current plus base current is equal to emitter current. Or if I say in the way which I stated it, then it will be IE is equals to IB plus IC. Emitter current is equals to base current plus collector current. Many of you must be thinking where this IB came from. It is when any of the majority charge carrier recombines with base current, then the place of one hole is being occupied an electron and also of the electron. Therefore, an electron enters to this base, which constitutes the IB current. Hope it was short enough to make pinpoints for our exams. Okay, all the best friends. Bye-bye. Please do comment in the comment box if any comments, and if you have any of the questions, doubts, then you can ask me. And if you like it, please do subscribe and press the like button. Bye-bye. Hello friends, common emitter NPN transistor characteristics. This is the topic for our video today. So let's get started. Okay. When a transistor is used in common emitter configuration, then the input is between base and emitter and output is between emitter and collector. The variation of base current IB with the base emitter voltage VBE keeping VCE fixed or constant is called the input characteristics. Variation of collector current IC with the collector emitter voltage VCE when IB is kept constant, then it is called output characteristics. Now, input resistance. This is defined as the ratio of change in base emitter voltage delta VBE to the change in base current delta IB at constant VCE. That is, Ri is equals to delta VBE upon delta IB whole in the bracket when VCE is constant. Now, output resistance R0 or Ri, this is defined as the ratio of change in collector emitter voltage delta VCE to the change in collector current delta IC, keeping IB constant. That is, if given in a mathematical equation R0 or RO is equals to delta VCE upon delta IC whole in the bracket, keeping IB constant. The output resistance is higher due to reverse bias of the junction. Also, current amplification factor. This is defined as the ratio of change in collector current to the change in base current, keeping VCE, that is, collector emitter voltage, constant. When stated in a mathematical equation, beta AC is equals to delta IC upon delta IB whole in the bracket, keeping VCE constant, or delta DC, that is direct current, is equals to IC upon IB whole in the bracket, keeping VCE constant. I hope, friends, that you must understood that whatever I said. For any of the doubts or any of the queries and suggestions too, please do comment in the comment box. Hope you like it. If you like it, please press the like button and please do subscribe. Okay, ta-ta, bye-bye. Full wave rectifier. For the positive half cycle, the diode D1 is in forward biased condition, and hence the current will flow through the load easily, and hence we will get an output. And this time the D2 diode is reverse biased. Then for the next half cycle, the polarity gets reversed, and now the diode will be reverse biased, and the D2 diode is in the forward bias condition, hence we will get the current from D2 diode. Now, since D1 and D2 diodes are forward biased one by one, but in both the half cycles there is current output, therefore we get, even if the polarity gets changed, we will get an output, but it will be DC, direct voltage current. But the frequency here remains the same. But as it contains central tapping transformer, so to avoid the use of central tapping transformer, we use bridge rectifier. In bridge rectifier, D2 and D4 are forward biased in the first half cycle, and at the same time D1 and D3 are reverse biased, and when the polarity gets changed, D1 and D3 are forward biased and D2 and D4 are reverse biased. In this condition also, both the time we do get the same current in the form of DC with the same frequency, but here no use of central tapping transformer is there, due to which it is easier to use and it is convenient to make bridge rectifier than as compared to half wave or full wave rectifier. So we end with the topic PN junction diode as a rectifier. For any suggestions or doubts, you can comment in the comment box, and if you like, do subscribe it and click on the like button. Thank you. Bye-bye. Tan, I'm back. So, welcome friends, and today we will discuss the semiconductors, in which we will discuss upon the special purpose PN junction diode. And for the first, it is Zener diode. Zener diode is a heavily doped PN junction diode. Due to heavy doping, its depletion layer decreases. It is less than 10 raised to the power minus 6, and internal electric field increases. Zener diode is a voltage regulator, constant output voltage power supply. Okay? Principle. It is based on the principle that under the reverse bias condition, after the breakdown voltage, the voltage across the diode remains constant even if current through it changes. Now, the necessary conditions for Zener diode. Vin is equals to IRS plus Vz, where Vin is the voltage in input voltage which is fluctuating, then IRS, RS is the resistance which is changing, plus Vz, which Vz is constant. Z is equals to reverse condition. Vin is a breakdown voltage. When the fluctuating voltage changes, that is increase or decrease, then the current through the series resistance and Zener diode increase or decrease respectively. This will change the voltage across RS, but the voltage across Z remains constant as it is working in the breakdown region. Since the load and Z are connected in parallel, therefore V0 is equals to Vz. Therefore, we get a constant output voltage even after fluctuating input voltage. To have good load regulation, current through diode will be greater than current through RL. RL is the load resistance. Generally, IZ is approximately 5 times the IL. Else, the value will be given to us. Okay. So here we end with the explanation of Zener diode and the principle. Also, the necessary conditions required for Zener diode when it acts as a voltage regulator. And so, friends, if you like this video, please do subscribe and give a thumbs up. If you want me to make other videos, please do comment in the comment box. Thank you, friends. Bye-bye. Tada. See ya.